Okay, once you have a drawing either generated on this computer that we supply with QCAD or any other computer that you have, save it to a USB or network through, save either SVG or DXF. We use DXF for any mechanical stuff, which we draw on either QCAD or on another computer with AutoCAD, Windows computer. And we use SVG for anything done in Inkscape, which is for us typically artwork. Once you have your drawing saved, we need to generate G-code. That's step 2. So it's a 3-step operation. First we draw it, second we bring it into SheetCam and generate G-code, and the third step we cut it out. So we start SheetCam. SheetCam is very easy to maneuver around. We have our parts loaded over here. There are tools available to us, which more can be added. And then the operations we're doing. First thing we need to do is bring in a drawing. So we import a drawing. It will remember the last folder that it came from, and you can also set up directories of where you want it to look at. I'm just looking in documents, so a test folder, a test program drawing. What you'll notice is down here, depending on what you saved it as, you need to make sure that you select that. For example, if I put SVG, I don't have any in there. So if you can't find your drawing, verify that you're looking for the right type of drawing. So in this case, DXF, I'm going to test one, open it. First thing it's going to ask me is how was it drawn? Was it drawn in metric, inches, or do we want to custom scale it? And then how we want to bring it in. I very seldom use any of these with the exception of drawing origin or bottom left. Drawing origin is a lot of times your drawings in your CAD programs are just done out in space. We don't have any, they're the correct size, but we don't have any idea where they're sitting in an XY grid. So by forcing it to pull to the bottom left, it'll automatically pull it to the bottom left. And you can see that our example of a square with a circle in it. Now, if I brought that in at drawing origin, you will see that it'll be just as I drew it, which is way out in space. So I recommend using most things bottom left. Okay, so we have our one part that contains 2 different layers in it. What we want to do is we want to cut the circle out first, and then we want to cut the square. Very easy. We go down here and create a new jet cutting operation. Tell it what kind of contour. Well, I want the torch to travel inside when I cut the circle out, on layer inside. What am I cutting it out of? Well, I'm going to cut this out of 10 gauge steel at 85 amps. We want to leave reverse cut direction selected for a hypertherm cutter. Minimum cut length for DTHC is how long the entity is for torch height control to be on. We have found that we run it typically between 4 and 6 inches. So anything that's smaller than 6 inches, torch height control will not be on, because most likely we're not going to get up to the recommended cutting speed, and we really don't need torch height control in such a small area. So this, based on a circle, is roughly a 2-inch circle is going to have torch height control on, and anything smaller than about 1.8 inch, 1 7/8, will not have it on. You can do different types of lead-ins, either none or 3 different types, and change the side. We typically use perpendicular lead-ins and arc lead-outs. So I'm going to do a decent sized lead-in of 300 thousandths. I'm going to do a lead-out of 100 thousandths. Okay, it's going to show me my path. As you can see, my blue is a rapid line. You see that it's going to start here on the scrap piece. It's going to cut. The red arrows are showing me what direction the torch is going to go. It's going to travel around. It's going to get back to where it led in, and it's going to lead out. If you get a male nub there, one thing you can do is force it to do an overcut. So I'll do 100 thousandths overcut. You now can see once it gets to where it led in, it's going to continue to travel 100 thousandths and then lead out. Once we're happy with this path, we can proceed to the next. This time we want to do an outside offset. On the outside layer, same material, I'm going to do the same lead in, same lead out with the same overcut. So I can just click OK. Now you can see that it's going to cut this first, loop around, then it's going to blue is the rapid move. Torch is lifted up 5/8 of an inch and moving over to the next pierce point, and then it's going to go here and cut in. Now we can edit our starting points by clicking this. We can control, so we click edit our starting point, then whatever layer we want to work with. And we can actually put our starting points wherever we want. Same thing on the inside layer. So once we have it exactly as we want, we're going to click this green button here that says Run the Post Processor. Okay, we're going to tell it where to save it. I'm going to save it in the Documents. Give it a name. I typically name them exactly the same as my DXF files or my drawing files so that I know they're a match set. However, you can give it any name you'd like, and choose Save. Dialog box will pop up. It says that processed the program with no error codes. We can automatically hide that if we don't want to see that. If there's no problem, it'll only pop up if there's a problem. And that is it. That is the basics of generating a path from a drawing you have.